Hello Vanguards. Today we have a lot on our plate. We're going to try and define what chemical bonds are. We'll explain why most atoms form chemical bonds. We'll try to describe ionic and covalent bonding and the properties of the compounds formed by this bonding. We'll explain why most bonding is sort of a compromise between ionic and covalent bonding. And we'll classify bonding type according to electronegativity differences. A chemical bond is an electrical attraction between atoms. And why do atoms do this? Well, they do this to obtain lower energy. Oftentimes, a chemical reaction will occur when the reactants over here on the left side of this graph have higher potential energy than the products, the things that are made, have. There are two main types of bonds, which I'm sure you have heard of before, and they're called ionic bonds and covalent bonds. Ionic bonds are formed by the attraction between cations and anions. Cations have a positive charge because they've lost electrons. Anions have a negative charge because they've gained electrons. If you look right here, you can see that calcium chloride is an ionic compound because calcium has a +2 charge. It's lost 2 electrons. And the chlorides on either side here have each gained electrons, so they have a negative charge at their anion. A covalent bond is going to look more like the second picture on the right, where you have 2 electrons that are being shared. Those 2 electrons that are being shared are called a covalent bond. And so this whole thing is called a molecule now. This entire calcium chloride unit is called a formula unit because it's ionically bonded. So you should probably take a moment, pause the video right now, and write down the properties of ionic versus covalent compounds. We will look at this in some detail in class. To really understand bonding, we have to deal with a term which is called electronegativity. Electronegativity is an atom's attraction for electrons. So the metals, the things to the left of the stair step, typically have a very, very low electronegativity. They have as many electrons as they want, and typically they want to even get rid of some electrons. They don't want more, so they don't have a high electronegativity. The nonmetals in green in this periodic table typically want more electrons, and they have a high electronegativity. They'll gain them. If there are electrons around, they will try to grab them. I really like this periodic table on the right side. I usually call it the skyscraper periodic table, and I call it that because it shows that on the upper right hand corner of the periodic table, elements like oxygen and fluorine and chlorine are sort of like skyscrapers. They have a very, very high electronegativity. They really, really want more electrons. Whereas the bottom left corner of the periodic table, francium and radium and cesium and barium, have a low electronegativity. Lots of times I'll copy and paste this one on the bottom right into your homework. And so these numbers here are the electronegativity. Notice that fluorine is the highest one here. It has an electronegativity of 4.0, just like up here in this periodic table. Also note that helium and neon and argon and also krypton and xenon and radon, the noble gases, they have basically an electronegativity of 0. They're happy as is. They don't want to gain any more electrons. The upper right hand corner has the highest numbers, but that does not include the noble gases. We're going to use electronegativity, and there's a symbol called delta En. This triangle means delta, and we'll use this to determine whether compounds are ionic or covalent. And so all we have to do is find the difference in electronegativity by using this table. To find difference, of course, we subtract. So you probably want to write down these numbers too, delta En and bond type. If 2 elements have a delta En greater than about 1.7, they're typically thought of as an ionic compound. If elements have an electronegativity difference of less than 0.3 or so, they're typically called a covalent compound, or better yet, a non-polar covalent compound. Well, what about the ones in the middle that are sort of, between ionic and pure covalent? They're called polar covalent compounds. So polar because they have holes, like positive and negative regions. Not quite ionic, where they're completely positive and negative, but partially positive and negative. And these polar covalent compounds have a delta En of between 0.3 and 1.7. And these numbers are subject to a little bit of variation depending on the shape of the compound. And once in a great while, we'll talk about percent ionic character. So the more ionic a compound is, the higher its percent ionic character, but we don't really use that very much in our class. These numbers up here I've put them on a number line down below here, and so here's your 0.3, here's your 1.7, the same numbers you had up above, and if the delta En, or the difference in electronegativity, is less than 0.3, you have a non-polar covalent compound. If you have a delta En of greater than 1.7, you have an ionic compound, and if the delta En, if the difference in electronegativity, so you subtract the two numbers, if that is between 0.3 and 1.7, you have a polar covalent compound. And in the bottom right hand corner, this is yet another diagram showing the different kinds of compounds. These two elements right here are perfectly sharing electrons. These two are sharing, but one of the elements gets more of the electrons than the other one. So this one's partially negative, this one's partially positive. If one of them has a complete positive charge and the other one has a complete negative charge, and they hang out next to one another because opposites attract, this is called an ionic bond. Let's do a couple sample problems using delta ENs. So here's a periodic table that has all the electronegativity numbers. Here's our buddy fluorine up here with a 4.0. Here's the table that we just had a minute ago, number line for you to look at as well. Let's pretend that oxygen was bonded with nitrogen. So the En values are, oxygen has an electronegativity of 3.5 and nitrogen has an electronegativity of 3.0. So the values are 3.5 and 3.0, and we subtract the two and we come up with a delta En of 0.5. And so what kind of bond type would this be? Well, if we look at our number line, 0.5 comes between 0.3 and 1.7, so it's a polar covalent compound. So it's a PC, polar covalent compound. Which is the more negative of the two? Well, the more negative is the one with a higher En, and that is oxygen, which has a 3.5. So oxygen is more negative. And we could also look at the percent ionic character and estimate that. So we should be, on the number line, we should be about here or so. So the percent ionic character might be, 13 or 14%, somewhere in there. But again, we won't be doing much of this percent ionic character business. Let's try oxygen and cesium. So here's oxygen again, there's our 3.5, and cesium is way over here. Cesium has a 0.8 value. So the difference between 3.5 and 0.8 is 2.5, 2.7. So the delta En is 2.7. Now that's a pretty major delta En, difference in electronegativity. So 2.7, that's way over here somewhere. So that's clearly an ionic compound. Which one ends up being more negative? The oxygen does, because its value is 3.5, so it gets that electron. And the percent ionic character is very high. It might be 80% or something like that. So that's how you use delta ENs. That is today's lesson. There was a lot there. Let's take a look at what we've done today. So the first thing was that we talked about chemical bonds forming so that they end up with lower potential energy, which is often the case, but sometimes there are exceptions to that rule. We talked about the two main types of bonds, ionic and covalent bonds. You wrote down the properties of ionic versus covalent compounds, and we talked about how we will cover this in great detail in labs. We looked at electronegativity, and we played around with some of the values here. We looked at the skyscraper periodic table in the upper right-hand corner and the simple periodic table in the bottom right. And we wrote down the numbers, the 1.7 and the 0.3, and we found out that if two elements have a delta En of greater than 1.7, that makes it an ionic compound. And if they have a delta En of less than 0.3, they'll be a non-polar covalent compound. And if they're between 0.3 and 1.7, you have a polar covalent compound. And we just played around with that a little bit more, and that was the entire lesson. So thank you, and if you have any questions, as always, remember to stop in and ask me for help and talk to your friends. Thank you. Bye.